Voyager 1 is an icon of space exploration. The longest-traveled probe of all time received a disturbing response from a nearby object in space, and NASA scientists were initially baffled. What had emitted the strange signals? Was it a natural phenomenon, a spacecraft, or a previously unknown force of nature? Far out in space, where Voyager 1 is now located, there seem to be far more unknown mysteries than we thought. Voyager 1 is a marvel of technology and an achievement of human engineering. The probe, which was launched in 1977, has since studied numerous planets, moons, and many other phenomena and features. It has traveled around 22 billion kilometers, and Voyager 1 is still communicating with Earth. In November 2023, things got dicey. Voyager 1 suddenly sent nothing but garbage data, and panic broke out at NASA. Had the longest-traveled probe of all time given up the ghost prematurely? For a long time, it really did look as if Voyager 1 was lost forever. Researchers had secretly hoped to be able to operate the probe until 2040. Its energy supply could actually last that long, but nobody knows how long the radio link can be maintained over such enormous distances. Voyager 1 is of inestimable value to science because the probe is located where no man-made object has ever been before, in interstellar space. This hitherto largely unknown medium between the stars forms the largest expanse of the universe. The space between the individual star systems is incredibly large, and in this mysterious space, researchers suspect many answers to previously unsolved questions about the true nature of the universe. What do all the cryptic data of ones and zeros mean? For 5 months, Voyager 1 sent only cryptic data. Endless loops of ones and zeros reached NASA's control center. The probe was clearly still alive. The data stream was unbroken. But the transmitted messages were suddenly incomprehensible and therefore useless to scientists. Even the best decoding machines and human experts initially struggled to decode the messages. Then an employee of the Deep Space Network, which supports the communication of the 2 Voyager probes, found the solution. Voyager 1 had sent a complete imprint of its memory system, only it was encrypted in a very special way. Many months passed, and NASA's hopes of being able to put the probe back into operation properly faded. This feat had already been achieved once before in 2021 when a telemetry problem had also resulted in unusable data. In early spring 2024, NASA's press officer had already announced that they were preparing to lose Voyager 1 forever. But then the probe started transmitting again. Since the beginning of April 2024, we have usable data again, and the Voyager adventure can continue. What was that mysterious data from the universe? Can you imagine what it's like to listen to the depths of the universe every day? Every day there can be a crazy surprise. The NASA employees monitoring Voyager's flight receive measurement data from the probe around the clock. Most of the instruments, and especially the cameras, have been switched off for a long time. At present, Voyager 1 only measures the density of the plasma and the strength of the magnetic field. This is perfectly adequate in the interstellar medium. It is so dark here that images would make no sense, and the only things that count for the scientists now are particle currents and radiation. Imagine the data as permanent noise, with fluctuations appearing here and there, signals from particles or plasma. It must be highly peculiar when a signal suddenly appears in this monotonous silence of the universe, astonishing everyone. It was like a mysterious cry when Voyager 1 suddenly reported a remarkably dense stream of particles or plasma. The unusual intensity of the signals indicated a completely new phenomenon. The signal seemed to the researchers as if a lively, bubbling source of something unknown had suddenly appeared in a desert. At first, NASA was at a loss. What could it be? The researchers were in for a big surprise. As soon as they entered the interstellar medium, Voyager 1 measured a much higher particle density than expected. In interstellar space, the density of particles drops dramatically compared to the interior of our solar system, with its permanent plasma flows. Our sun forms a protective shell around itself and all its planets. Scientists call this shell the heliosphere. Within the heliosphere, there are around 100 particles per surface unit. In the space between the stars, there is probably only one particle in the same area. Although the particle density fell as expected in the free universe, there were far more particles present than the calculations had shown. This initially means that the interstellar medium is denser than we thought. From a physical point of view, a few particles can have a huge impact. We have to wait and see what this hitherto largely unknown medium will bring us. This is precisely why the Voyager probes are of such great value to our science. The strange stream of particles measured by Voyager 1 in 2023 seemed to upset our understanding of interstellar space once again. A stream of this intensity could be some kind of interstellar flare, but if so, what was the source? Voyager 1 is very far out in space, and yet in cosmic terms, the probe has only just flown out of our solar system. If we were to place Voyager 1 on Earth in Berlin, the nearest star would be, to scale, in Beijing. Between these two cities, there would be simply a vast expanse of nothingness. It is unlikely that a stellar flare would travel that far through space. What other sources are possible for this strange signal from the universe? Theories abound, with some suggesting it could be traces of a previously unknown force, and some scientists even speculating that it could be an alien intelligence's response to Voyager 1. What happened to Voyager 2? Voyager 1 did not launch alone. That is common knowledge. But what is less well known is the fact that Voyager 2 followed a completely different trajectory than its twin. Voyager 2 was the first of the two space heroes to launch in 1977, but it was the second to arrive at the outer planets. This was because Voyager 2 maneuvered very differently from Voyager 1. In the 1970s, scientists used the two probes to try out different techniques of acceleration, flyby maneuvers, and navigation. Although both probes are technically exactly the same, the routes they were sent on differed significantly. Voyager 1 took a more direct and dangerous course through the asteroid belt between Mars and Jupiter, while Voyager 2 was accelerated by many flyby maneuvers at various planets. Both reached their destinations and sent us unforgettable images of the outer planets and moons. We have the two probes to thank for the first real moving images of Jupiter. For the first time, researchers were excited to see the moving surface of the gas giant. Voyager 1 also gave us the first images of the Great Red Spot, and since its mission, we know that this striking feature of Jupiter is also a storm in constant motion. Voyager 1 also photographed Jupiter's moons Io, Callisto, and Ganymede. The probe observed an active volcano on Io, proving that there is geological activity on other celestial bodies. Voyager 2 provided us with more detailed images. For the first time, it photographed Jupiter in true color, and humanity was amazed at the beautiful brownish marbling of the planet. Once again, this probe provided us with breathtaking images of the fascinating moons of the outer solar system. After exploring Saturn, Voyager 1 and 2 parted ways again. While Voyager 2 was the first probe to reach the planets Uranus and Neptune, Voyager 1 was already on its way to the outer regions of the solar system. Voyager 2 followed it after completing its primary mission, and both probes successfully crossed the heliosphere many years later. Nobody really expected this in 1977. The fact that these brave heroes of space exploration would still be flying and sending data so many decades after their launch was nothing short of a miracle. Today, Voyager 2 is also quite far out in the interstellar medium. In July 2023, unfortunately, there were also serious problems with Voyager 2. NASA was once again trembling and eagerly searching for a solution. Once again, the engineers achieved the unbelievable and brought the probe back into its regular orbit over a distance of more than 18 billion kilometers. Since August 2023, Voyager 2 has been sending data back to Earth as usual. Today, a signal needs more than 22 hours to cover the one-way distance. The radio transmission over this enormous distance is another miracle of this mission. The data is transmitted by the antennas of the two probes. These antennas are always pointed towards the Earth. 3 large receivers located in California, Spain, and Australia capture the signals and forward them to NASA's control center in Pasadena. The Deep Space Network is a global communication system that oversees many interplanetary research missions and space communications. NASA is now optimistic again. The technicians have now been through so many adventures with the Voyager probes that they hope to be able to operate them for a few more valuable years. The Voyager probes use radioisotope thermoelectric generators to generate energy. These generators are based on the heat generated by the decay of plutonium-238. As the plutonium decays extremely slowly, their energy supply has been secure for decades. However, this ingenious technology is slowly coming to an end. Scientists hope that the electricity will last at least until the mid-2030s. Even if contact is broken off one day, the mission will still continue. The Voyagers are virtually indestructible and will still be flying through space thousands of years from now. In the event that the two are one day found by an alien species, they each have a golden record on board that can be played by any halfway technologically advanced society with simple instructions. Should this simply be the case one day in the distant future, aliens somewhere in the universe would hear the sounds and music of our Earth. They would listen to the twittering of birds and the murmur of a brook. They would hear the laughter of children and possibly be amazed or even enraptured by the compositions of Beethoven or Mozart. Whether we will ever receive an answer is written in the stars.